Hello everyone. Today we're going to talk about parameter changes to the linear parent function. Now, linear function is a word that you've heard me saying a lot in the past unit, and it requires a little bit more explanation. Let's look at the word linear. If you notice, within the word linear, we have the word line. So basically, a linear function is just simply the graph of a line. So a linear function always looks like a line. All of the functions or equations that we have been graphing have all turned out as lines. Now, the most basic linear function, the parent function as we call it, it's the one who started it all. It's the one that all of the other linear functions resemble. The linear parent function is y equals x. And we graphed that when we did our body style graphing. And remember, we said that in a linear function, the slope is 1, because we can put a 1 in front of the x. So m would equal 1. And the y-intercept is 0. So b would equal 0. So that's the linear parent function, the one that started it all. And today we're going to talk about what happens when we change the parameters of the linear parent function. What happens to the line? And the parameters are simply the m and the b. What happens when we make changes to the slope and y-intercept? How does the graph of the line change? So we're going to go down to our first graph, and you're going to need a ruler and several different colors, because we'll be graphing different lines and we want to graph them in different colors to see how they change. So the first line we're going to graph is y equals x. And we already said that the slope of that is 1 and the y-intercept is 0. So this has a slope of 1 and a y-intercept of 0. So we'll start by graphing the y-intercept. The slope would be 1 over 1, so we'll go up 1 and right 1. And then we'll move down and left a couple of times. And there's our linear parent function. So you can see that the linear parent function goes straight through the origin, straight through the center of the graph, and has a slope of positive 1. Okay. Now we're going to keep the slope the same in all of these equations, but we're going to make some changes to the y-intercept. So now we're going to have a y-intercept of 2 and a slope of 1. So here's a y-intercept of 2 and then a slope of 1. So up 1 and right 1, up 1 and right 1, down 1 and left 1, down 1 and left 1. So we'll graph that line. And as we're graphing the lines, I want you to notice how the line is changing. Okay, now we're going to graph, and I'll just underline this one in pink, because that's the pink line. Now we're going to graph y equals x plus 5. So again, our slope is staying the same, but our y-intercept has changed to 5. So we'll start this one at 5 on the y-axis. We'll move up 1 and right 1, up 1 and right 1. down 1 and left 1, down 1 and left 1. So how do you notice that these lines are changing? Okay, now we're going to graph y equals x minus 3. So our y-intercept is going to be -3 this time. So we'll start down at -3 on the y-axis and move up 1 and right 1, up 1 and right 1. Remember, our slope is not changing, just our y-intercept. Down 1 and left 1, down 1 and left 1. Okay, and the last one we're going to graph is y equals x minus 7. So our y-intercept this time has changed to -7. -7, our slope is still 1. So all of these lines have the same slope but different y-intercepts. Okay, so now that we have those graphed, I would like you guys to pause the video and try your best to answer question number 2 on your own. Okay, you're going to summarize the effects of changing the value of b, or the y-intercept, and y equals mx plus b. How has our parent function changed as we changed the y-intercept? And you go ahead and put it in your own words and then press play, and we'll talk about our conclusions. Okay, so we can see that as we changed the y-intercept in the first two equations, in B and C, the line moved up along the y-axis. In the second two equations, we notice that the line moved down along the y-axis. So the effect of changing the y-intercept is to move the line up and down, up or down along the y-axis. So we can just say that the line moves up or down along the y-axis. Okay, let's look at 3 together. Describe in words the effect on the graph from 2x plus 4 to 2x minus 1. So let's just draw our own little graph out here. So if we were to graph the line 2x plus 4, it would have a y-intercept of positive 4. And I'm not going to graph the whole line. We're mainly concerned about the y-intercept because the slopes are the same. If we were to graph y equals 2x minus 1, it would have a y-intercept of negative 1. So I'll just sketch in the graphs. We're not going to worry about the slopes because the slopes are the same. So we can see that this line shifted down. How many units did it shift down? We can see that it shifted down 1, 2, 3, 4, 5 units. So we can say the line shifted down, and another word we can say is translated. Say was translated. The line shifted down 5 units. Or the line was translated 5 units down. Pause the video and answer 4 and 5 on your own, and then we'll review the answers together. Okay, so what is the effect on the graph of y equals 1/2 x minus 6 if the negative 6 is changed to 2. So we're going to take this equation and we're going to keep the slope the same but change the y-intercept to positive 2. So let's draw ourselves a little graph out here. So the original y-intercept was at all the way down here at negative 6. And the new y-intercept is going to be up here at positive 2. So the graph is being translated up. How many units is it being translated up? Well, we have to go up 6 to get to 0, and then we have to go up another 2 to get from 0 to 2. So we can say that the graph is translated up 8 units, because we're going up a total of 8 units. If the graph of y equals 4 minus 6x is translated 9 units down, what would be the equation of the new line? So if we are translating the graph 9 units down, that means that we are going to change the y-intercept. And if we're going down, we're going to subtract from the y-intercept. So we need to subtract 9 from the y-intercept because it says translated 9 units down. So our y-intercept right now is 4. So 4 minus 9 is going to give us a negative 5. So the new equation would be y equals negative 5 minus 6x. Remember not to get tripped up by the y-intercept being the first in the equation. The y-intercept is always the one without the x, regardless of whether it comes first in the equation or it comes second in the equation, like right here. And I know that my paper was down below where you couldn't see it, so let me just go over this again. Our original y-intercept was 4. It says, the problem says translated 9 units down, so we're going to subtract 9 from the y-intercept. 4 minus 9 gives us negative 5. So the new equation would be y equals negative 5 minus 6x. So we changed our y-intercept from 4 to negative 5. Okay, turn over to the back page. So far we've investigated what happens when we change the y-intercept of the parent function. Now we're going to explore what happens when we change the slope of the parent function. So here is our parent function. Remember, it has a y-intercept of 1 and, a slope of 1 and a y-intercept of 0. So we're going to graph that parent function again as we did on the other graph, y-intercept of 0, slope of 1, which means we move up 1 and right 1, down 1 and left 1, down 1 and left 1. So again, there's our parent function. It goes through the origin, it goes through 0, 0, and it has a slope of positive 1. Now we're going to start making some changes to the slope of the parent function. So we're going to keep the y-intercept the same, and we're going to change the slope this time to 2. So our line is still going to have a y-intercept of 0, but this time our slope is 2 over 1. So we'll go up 2 and right 1, up 2 and right 1, and then we'll move down 2 and left 1, and down 2 and left 1. So there's the line. Okay, and just start to observe what changes you see in the line as we change the slope. So now we're going to keep our y-intercept at 0, but we're going to change our slope to 3. So the y-intercept is still 0, still starting here, but slope is 3 over 1. So up 3 and right 1. And then we'll go down 3 and left 1. Oops. Okay, so far we have graphed the parent function in red. We've graphed y equals 2x plus 0 in brown. This one has a slope of 2 over 1. And then we've graphed y equals 3x plus 0. That's the pink line. It has a y-intercept of 0 and a slope of 3 over 1. So up 3, right 1. Okay, now we're going to change the slope again. This time our slope is a fraction. It's a number between 0 and 1. So our y-intercept is still 0. Our slope is 1 over 2. So we're going to go up 1 and right 2. Up 1 and right 2. Up 1, right 2. We can also go down 1 and left 2. Down 1 and left 2. So there's our new line. And as you're doing this, just try to start to think in your mind, how are these lines changing as we change the slope? Okay, now we're going to do y equals 1/4 x. So y-intercept still stays at 0, but our slope is going to be 1 over 4. So up 1 and right 4. Up 1 and right 4. Now we'll go down 1 and left 4 and down 1 and left 4. There we go. So what is happening to these lines? Now our last one, we're going to graph y equals -4x. So now our slope is negative instead of positive. Same y-intercept, but this time we're going to go down 4 and right 1 because we have a negative slope. Down 4 and right 1. So this is the only line with a negative slope, so it should have a different slant than all the other lines if we're graphing it right. Up 4 and left 1. Up 4 and left 1. Okay, so yes, we can see that it does have a different slant than all of the others. Okay, so now what we want to do is we want to look at our lines and we want to list them from the most steep to the least steep. So think of a hill. Which would be the hardest hill to climb? Okay, and don't worry right now about whether it's a negative slope or a positive slope. Just think of trying to climb up that hill. Which would be the hardest to climb? Well, definitely this one. If we tried to climb up this hill, that is a very steep hill. So y equals -4x is going to be our most steep. And then our next is going to be y equals 3x. And then our next one will be y equals 2x. And then our next one is our parent function, the y equals x. The next one is this gray line, which is y equals 1/2 x. And then the next one would be, the least steep would be our blue line, which is y equals 1/4 x. So we want to summarize the effects of changing the value of m. What happens when we change the value of the slope? Pause the video and put it in your own words, and then we'll discuss the answer. Okay, so when we change the value of m, the further the slope is from 0, the steeper the line. Okay, so the further the slope is from 0, the steeper the line. Because we can see 1/4 is the closest number to 0. And then gradually 1/2 and 1 and 2 and 3 and even -4 are getting further from 0. If we look at our number line, -4 is the furthest from 0. We're not worried about whether it's positive or negative. We're not worried about which direction from 0, but just how far is it? How many units is it from 0? So we can say the further the slope is from 0, the steeper the line. Okay, so we're going to describe in words the effect of changing the graph from y equals 3x plus 4 to y equals 3/4 x plus 4. So we want to know, would the graph get steeper or would it get less steep? So we're starting with 3x plus 4 and we're going to 3/4 x. So are we getting closer to 0 or further from 0 as we go from 3 to 3/4? Well, we're getting closer to 0. So we would say that the slope is getting less steep, or the line is getting less steep, because the slope went closer to 0. 3/4 is closer to 0 than 3. So we're going to say that the line will be less steep. Okay, so what would be the effect on the graph y equals 1/2 x minus 6 if the 1/2 is changed to 4? So we're going to change the slope in the equation. We're going to change the 1/2 to a 4. So what would be the effect of changing from a slope that is close to 0 to one that is further away from 0? Well, the answer is that the graph would become more steep. Okay, try to do number 6 on your own. Press play when you're ready to check your answer. If the slope of the graph y equals -2x minus 4 triples, what is the effect on the graph? So right now the slope is -2. If we triple -2, that means we're going to multiply it by 3. So that would give us a new slope of -6. So the new equation would be y equals -6x minus 4. So what would be the effect on the graph if we change the slope from -2 to -6? Well, if you think of the number line, we're at -2 and we're going to move to -6. So we just moved to a slope that is further away from 0. So that means that the graph will get steeper. So the graph would become more steep. Okay, so to sum it up, changing the y-intercept in a graph will shift the graph either up or down along the x-axis. Changing the slope in a graph will make the line either steeper or less steep. The further the slope number is from 0, the steeper the graph will be. The closer the slope number is to 0, the less steep the graph will be. See you tomorrow in class.